At 0600 hours local time, the MiG-29 sat silent inside its concrete revetment at Katchcha airfield in Crimea. Its engines cold, its pilot asleep a short walk away, unaware that the aircraft's hunting days were already over. For weeks, this jet had prowled low-altitude corridors above the Black Sea, intercepting Ukrainian reconnaissance drones, calling coordinates to air defense batteries, and building a reputation as a reliable predator in Russian airspace control. Tonight, there would be no scramble order, no warning tone, and no chance to climb. 400 kilometers away, long before dawn reached the coast, a weapon was already in the air on a trajectory designed to make sure this fighter never flew again. The Russians did not know it yet, but the clock had already started counting down toward a result they could no longer influence. At the same moment, the MiG rested in darkness. A pneumatic catapult fired west of Katchcha, hurling a UJ-26 Beaver drone off its launch rail with a sharp mechanical crack that vanished into the wind. Its rear-mounted propeller caught immediately, pulling the composite airframe upward to 60 meters before leveling into cruise. The sound signature dropped almost instantly, quiet enough that a soldier standing 500 meters away would hear nothing but grass moving in the breeze. 3 Ukrainian special operations soldiers had less than 2 minutes to disappear. They folded the launch rail in 12 seconds, buried thermal blankets under gear in the truck bed, and rolled away along a dirt track parallel to an irrigation channel. The Beaver was already 2 kilometers downrange, accelerating toward a destination 398 kilometers southeast. 14 miles east, a Pole 21 electronic warfare tower registered an anomaly almost the instant the drone powered on. Passive receivers blanketing the corridor were tuned to detect satellite navigation signals, and the Beaver's encrypted handshake produced a brief frequency-hopping burst in the L-band. It lasted only 4 milliseconds, barely enough to raise the noise floor, but enough for a duty officer with Rubicon, Russia's dedicated drone hunting unit, to flag it as suspicious. A possible long-range launch, general coordinates in the Kherson sector. Within minutes, an Orlan 30 surveillance drone lifted from a nearby site and began sweeping thermal imagery across fields and roads, searching for the fading heat of a vehicle that could not have gone far. Watching the Beaver climb through 400 meters explains why Rubicon prioritizes killing operators instead of chasing drones. The airframe measures roughly 2.5 meters from nose to tail. Fiberglass composite stretched over a canard configuration with small forward wings for pitch control and a swept main wing for lift. A rear-mounted propeller pushes it at 160 kilometers per hour, while composite construction produces a radar cross-section between 0.01 and 0.03 square meters, smaller than most birds. At night, flying low over terrain clutter, the drone is nearly invisible to Russian air defense. The people who launched it are not. Rubicon understands that trained crews take months to build, months of learning emission discipline and autonomous navigation under pressure. Eliminate them, and Ukraine loses something far more valuable than a single drone. The Orlan's thermal camera operated in the 3 to 5 micron band, sensitive enough to detect a vehicle engine that shut down 20 minutes earlier. Residual heat decays at roughly 2 degrees Celsius per minute, leaving a detectable signature for another quarter hour. The Ukrainians knew this. They pulled into a collapsed barn, shut down the engine, and draped thermal blankets across the hood and roof. For 8 minutes, they sat motionless in absolute silence while the Orlan passed overhead. On its display, a ghost image flickered where the truck had idled, compressed grass still warm beneath the tires. The operator vectored toward the anomaly, prompting Rubicon to dispatch 2 FPV hunter teams carrying lightweight drones designed to saturate search sectors and force mistakes. Each FPV weighed less than a kilogram, flew at 120 kilometers per hour, and carried a fragmentation charge capable of destroying a vehicle engine. Their advantage was numbers. A single team carried 6 to 8 drones, enough to blanket likely escape routes while flying 10 to 15 meters above ground, where thermal signatures blended into clutter and acoustic noise stayed below ambient levels until the last seconds. Russian doctrine assumed operators would flee fast after launch. The Ukrainians did neither. They stayed hidden as an FPV passed 400 meters east, its camera sweeping past the barn's collapsed roof without pausing. 50 kilometers away, the Beaver climbed toward its 800-meter cruise altitude and entered complete silence. No uplink, no telemetry, no emissions of any kind, trusting its navigation system to carry it onward while its operators focused only on staying alive. At 0616 hours, the Orlan passed directly over the barn and registered nothing but ambient temperature. No vehicle, no personnel, no target. Rubicon logged the search as inconclusive and escalated the hunt outward. The Beaver crossed the Dnipro River 19 minutes later, flying southeast toward Crimea on a heading that would take it over more than 200 kilometers of open steppe. There was no terrain masking here, no cloud cover, just just a composite airframe the size of a dining table moving through radar coverage that extended hundreds of kilometers in every direction. Yet Russian air defense networks saw almost nothing. Radar detection depends on wavelength, target size, and aspect angle, and the beaver's skin absorbed and scattered energy instead of reflecting it. At grazing angles, when beams struck from below at shallow incidents, returns dropped to near zero. Russian S-band search radars could theoretically detect a target with a radar cross-section of 0.03 square meters at 40 to 50 kilometers, but only if geometry was perfect. The beaver's flight path had been calculated specifically to avoid those conditions. It flew on inertial navigation, its GPS receiver active but silent, tracking acceleration and rotation through gyroscopes and accelerometers. Dead reckoning introduced drift, roughly 30 to 40 meters per minute without correction. But over a 400-kilometer flight, the accumulated error remained under a kilometer. That margin was acceptable because terminal guidance would allow correction later, assuming contact could be safely re-established. Back at Rubicon's operations center, analysts began reverse vector reconstruction, plotting fleeting radar paints into a backward cone pointing toward the probable launch area. The beaver had been briefly detected twice, once by a Crimean early warning radar and once by a mobile S-300 acquisition unit. Each contact lasted less than 2 seconds, insufficient for engagement but enough to establish bearings. The cone narrowed to a 20-kilometer corridor centered on the launch sector. A second wave of Orlan drones lifted, and FPV teams repositioned to cover bridges and canal crossings. Somewhere inside that corridor, 3 Ukrainians waited in silence, knowing they could not warn the drone without revealing themselves. At 0700 hours, the beaver's flight computer registered a navigation anomaly. Satellite signal strength dropped from 5 to 3, then flickered to 2. Position accuracy degraded from sub-meter precision to a 50-meter error circle that jumped unpredictably. Russian electronic warfare had found the approach corridor. ZTOL jamming systems mounted on trucks along likely UAV routes began flooding GPS frequencies with noise. Each system used directional antennas broadcasting hundreds of watts in 60-degree cones, overlapping coverage zones to create a continuous blanket. GPS satellites transmitted weak signals from tens of thousands of kilometers away, and even modest interference could overwhelm them. The beaver's computer switched to inertial-only mode as drift began accumulating immediately. 3 ZTOL vehicles were positioned along the Crimean approach, forcing the drone to accept increasing error with every passing minute. Over the next hour, drift would reach nearly a kilometer, recoverable, but only if operators could re-establish contact during terminal guidance. In the barn, the Ukrainian team monitored their relay status panel. The beaver was far beyond direct radio range, and emission silence was mandatory. They could not see where it was or whether it still flew. All they could do was trust the system they had built. Meanwhile, Rubicon's FPV hunters continued sweeping the corridor, unaware that their quarry was still close. At 0714 hours, another FPV passed within 400 meters of the barn. Its thermal camera lingered briefly, then moved on. The collapsed roof created an irregular heat pattern that masked the truck inside, and the blankets had cooled to ambient temperature. Rubicon was not trying to shoot down the beaver. Commanders understood that long-range composite drones routinely defeated short-range air defenses. Shooting one down meant little if more followed. Trained operators were the true objective. Rubicon's doctrine was simple: remove the humans and the drone program collapses with them. At 0721, confident the immediate hunt had moved on, the team restarted the truck and rolled south toward a safe house 14 kilometers away, while the beaver closed to within 180 kilometers of Katchcha airfield. At 0759 hours, the beaver crossed into Crimean airspace, now less than 100 kilometers from Katchcha airfield. Its onboard computer activated the optical guidance camera and began transmitting a narrow beam uplink toward a relay station hidden inside Ukrainian-controlled territory. For the first time in nearly 2 hours, the operators could see what the drone saw. The video feed was grainy and compressed to preserve bandwidth, jittering with latency that made every correction feel delayed. Through the noise, the airfield emerged as a gray smear of concrete and blast walls, slowly resolving as the drone descended. The MiG-29 sat parked in its revetment, nose protruding just enough to be visible beyond the protective walls. The operator identified the target and began issuing small steering inputs, compensating for inertial drift accumulated during jamming. What he could not see was that Rubicon detected the uplink almost instantly. Even tightly focused directional antennas produce side lobe leakage, stray radio energy spilling beyond the main transmission path. Russian signal intelligence arrays along the Crimean coast were calibrated to detect exactly this signature. Within 4 seconds, they had a bearing. Within 8, 3 stations triangulated the approximate position of the relay source to within 200 meters. From first detection to firing solution, 11 seconds elapsed. By the time the Ukrainian operator completed his first correction, Rubicon already knew where to shoot. The bearing pointed back along the same corridor Rubicon had been searching for hours, toward a bomb-damaged apartment complex far from the original launch site. Rubicon responded with everything available. FPV drones launched along the triangulated line, a Lancet loitering munition vectored toward likely vehicle routes. Artillery coordinates were sent for immediate approval. None of this was visible to the Ukrainian team. Their attention was locked entirely on the screen as the MiG grew larger in frame. Latency forced the operator to anticipate movements rather than react, adjusting for a delay measured in fractions of a second that felt like an eternity. At 0805, the first artillery shell landed 2 kilometers behind the safe house. The team froze, but the relay signal remained stable. Rubicon had their grid now, and more rounds were coming. The operator forced himself to ignore the distant impacts and focus on the approach. The Beaver was 2 kilometers from the target, 90 seconds to impact. A second shell fell closer, 1,000 meters east. The security element reported FPV drones inbound from the north, closing fast. At the same moment, the operator noticed the accumulated navigation error. Inertial drift had pushed the Beaver 340 meters left of the aim point. Without correction, it would strike empty concrete. He needed one adjustment, a 3-degree heading change requiring less than 2 seconds of transmission. He sent it. The command uploaded successfully, locking into the Beaver's flight computer. The operator continued steering as the MiG filled the frame. 60 seconds remained. Unknown to Rubicon, the relay station they were targeting was unmanned, a deliberate sacrifice positioned precisely because Russian doctrine demanded immediate destruction of any transmission source. The Ukrainian team was nowhere near the equipment Rubicon believed they were killing. On Rubicon's tactical display, bearing lines converged on the ruined apartment block. The lead FP5 dove at a steep angle, camera fixed on a rooftop antenna array. Speed mattered more than confirmation. The first drone struck dead center, its fragmentation charge detonating and collapsing the roof. The second hit seconds later, detonating inside the structure. The third ensured nothing remained intact. Artillery continued to fall, pulverizing the grid coordinate into rubble. Thermal imagery showed no movement. Rubicon logged the mission as successful. The operators had been neutralized. That assumption cost them everything. The final correction was already stored. The Beaver no longer needed guidance. Its nose remained aligned on the MiG as it entered terminal dive, descending rapidly toward a target that could no longer escape. At 0806 hours and 34 seconds, the Beaver struck the MiG-29. The 20-kilogram shaped charge detonated instantly. The pressure wave ripped through aluminum skin from nose to tail. Cockpit disintegrated. Fuel sprayed across the revetment and ignited a fraction of a second later. Flames surged skyward, secondary explosions rippling through the airframe as ammunition cooked off and hydraulic lines burst. When the fire settled, nothing remained but a blackened skeleton of twisted metal. The explosion at Katchcha airfield registered across multiple sensor networks within seconds. Infrared satellites detected a sudden heat bloom where the MiG had been parked, followed by a rapid drop as fuel finished burning and structural materials cooled. Russian base security scrambled, but there was nothing to secure. The revetment was a cratered shell, the fighter reduced to warped spars and melted wiring embedded in scorched concrete. Fire crews arrived to find no secondary threats, no unexploded ordnance, and no survivors to recover. Whatever investigation followed would start from the same conclusion. The aircraft had never been airborne. It had been destroyed where it slept. Inside Rubicon's operations center, confidence began to erode as reports arrived out of sequence. The relay station they believed destroyed had indeed been eliminated, but follow-on signals indicated the strike had still succeeded. Analysts replayed the last seconds of data, trying to reconcile how a supposedly unguided drone had achieved a direct hit. The 3-man Ukrainian team listened to distant detonations from their basement shelter, counting the seconds until the relay went silent. When it did, they did not move. They waited, knowing that Rubicon would saturate the grid coordinate long after the target was gone. Only after thermal sensors confirmed the barrage had ended did they begin exfiltration on foot, abandoning the vehicle entirely. By then, the Beaver's mission was already complete. The drone no longer existed. Its role had ended at impact, its value fully expended in a single, irreversible moment. Russian commanders would later characterize the destruction of the MiG as an unacceptable lapse in perimeter defense, a failure of guard rotations, sensor coverage, and hardened shelter placement. That explanation was convenient because it framed the loss as a localized mistake rather than a systemic problem. But inside staff briefings, the discussion quickly moved beyond fences and patrol. The uncomfortable truth was that the aircraft had not been lost because defenses were weak at Katchcha airfield. It had been lost because the assumptions underpinning those defenses no longer matched the reality of modern long-range strike warfare. The perimeter had worked exactly as designed against threats it understood. The attack simply did not belong to that category anymore. The operation demonstrated with brutal clarity that long-range, one-way drones did not require persistent control to be effective. Continuous uplinks, once considered essential for precision, had become optional rather than mandatory. The Beaver tolerated navigation drift measured in hundreds of meters, survived prolonged GPS denial, and still achieved a lethal hit using a terminal guidance window measured in seconds. This was not an accident or luck. It was the result of deliberate design choices that accepted imperfection in exchange for reach. Russian planners had built their counter-drone doctrine around the idea that breaking control links meant neutralizing the threat. That belief no longer held. Electronic warfare, long viewed as a decisive counter, revealed its limitations. Jamming had forced the drone into inertial navigation and degraded accuracy, but it did not stop the mission. The system succeeded technically while failing operationally. By creating pressure to force emissions, they exposed their own predictability. The Russians had invested heavily in denying guidance, but not enough in denying opportunity. The drone only needed one clear moment near the end of its flight. Everything before that was expendable. That asymmetry favored the attacker, not the defender. Air superiority offered no protection in this equation. The MiG had dominated its patrol sector for weeks, intercepting slow reconnaissance drones and directing surface-to-air fire with confidence. In the air, it was lethal. On the ground, it was inert. Once parked, its speed, maneuverability, and sensors meant nothing. It became a static object with known coordinates. The strike reinforced a reality that modern air forces are still grappling with. Control of the sky does not guarantee safety on the ground, especially when the threat does not need to contest airspace to be effective. The immediate operational response reflected this shock. Patrol patterns over the Black Sea shifted within hours. Sortie rates dropped as commanders reassessed risk, dispersing remaining aircraft to secondary fields, rather than concentrating them at familiar bases. Jets that had previously rotated through predictable schedules were now moved irregularly, increasing logistical strain and reducing efficiency. The goal was not to regain dominance, but to reduce vulnerability. Every parked aircraft now carried an implicit question. How long had it been targeted already? Air defense priorities changed just as quickly. Systems once optimized to protect runways and approach corridors were repositioned to cover parking areas, shelters, and maintenance zones. Resources were diverted toward guarding assets that were no longer moving. This redistribution did nothing to change the outcome at Katchcha. It only acknowledged that the battlefield had shifted. Defenses were reacting to a lesson already delivered, not preventing it. The material cost of the loss was easily calculated. A single fighter airframe, its onboard systems, fuel, and stored munitions destroyed in seconds. But the deeper cost was harder to quantify. Confidence had been damaged. The Russians had believed they understood the engagement cycle. Detect the launch, reconstruct the vector, hunt the operators, and the drone threat collapses. That sequence had been reliable until it was not. At Katchcha, every step of that cycle had been executed, and it still failed. The most troubling realization was how little margin there had been for correction. Once the drone was launched, the window for intervention closed rapidly, killing the relay, destroying the presumed operators, and saturating the area with fire had all come too late. The decisive moment had occurred earlier, when the final heading correction was uploaded. From that point on, the outcome was locked in. The defenders were acting in real time against a decision that had already been made. By the time dawn reached Crimea, the revetment at Katchcha was still smoking. The concrete retained heat where metal had burned away, and the outline of the aircraft was visible only as a darker stain against scorched ground. A fighter that had spent weeks hunting drones had been erased without ever leaving the ground. Its pilot would wake to an absence rather than an alert, confronted with the knowledge that the threat he had pursued so confidently had found him first. Far from the airfield, the operators who enabled the strike were already gone. They moved through terrain that would soon be searched again, but for signatures that no longer existed. The sky over the Black Sea remained empty, calm, and deceptively quiet. Nothing in that stillness hinted at the planning, patience, and acceptance of risk that had turned a sleeping aircraft into a target hours before its pilot closed his eyes.